Chapter 8. The Database Administrator Who Never Calls in Sick. It was 3 a.m. when the alert came in. The database server needed a security patch, the kind that required a restart. The vulnerability was real, the patch was available, and the window for applying it without disrupting customers was right now, in the middle of the night, when traffic was low. Priya was the only one awake. She applied the patch, restarted the server, watched the logs until the application came back online, and went to bed at 4:15 a.m. In the morning, she told the team what had happened. There was a silence. "That's going to happen again," Tom said. "It's going to happen every time there's a patch," Priya said. "And there are always patches. There has to be a better way to do this." There was. It just required giving up the idea that they needed to manage the database themselves. The traditional database problem. When you run a database yourself on an EC2 instance, you're responsible for everything. Installing the database software, configuring it securely, patching it when security vulnerabilities are discovered, taking backups, testing that the backups actually work, a step most teams skip until it's too late. Monitoring disk space, setting up replication for redundancy, configuring failover for when the primary server goes down, tuning query performance, managing connections under load. None of this is the application. None of it adds features. All of it requires expertise. Most development teams are not database administrators. This creates a predictable pattern. The database is installed, configured minimally, and then mostly forgotten until something goes catastrophically wrong. "Is that what we did?" Maya asked. Leo's answer was silence, which was the same as yes. Amazon RDS, the managed database. Amazon RDS Relational Database Service handles the operational burden of running a relational database so you don't have to. With RDS, AWS manages installing and patching the database engine, automated backups stored in S3 retained for up to 35 days, automated failover. When the primary goes down, a standby takes over automatically, monitoring and metrics, encryption at rest and in transit. Storage auto-scaling. If you enable it, the disk grows when it gets full. You manage the database schema, the structure of your tables, your queries and application logic, who has access to the database, which instance type runs the database, parameter tuning, though RDS provides sensible defaults. The analogy: hiring a database administrator who never takes sick days, never makes configuration errors, automatically takes daily backups, and fixes themselves if something breaks, but who doesn't write your application logic. Supported engines. RDS supports several popular database engines. The most widely used open-source relational database, PostgreSQL. Powerful, extensible, increasingly popular for complex workloads. MariaDB, open-source MySQL fork, fully compatible. Oracle, enterprise-grade, used in large organizations with legacy requirements. Microsoft SQL Server, for Windows-heavy environments. Amazon Aurora, AWS's own MySQL PostgreSQL-compatible engine, built for the cloud. We cover Aurora deeply in Chapter 24. For Nimbus, the choice was PostgreSQL. It was what Leo knew, and it handled relational data well. The engine choice matters less than you'd think for most applications. The operational benefits of RDS apply regardless. Multi-AZ, the standby that takes over. This is the feature that changes the reliability calculus completely. Multi-AZ deployment means RDS maintains a synchronous standby instance in a different availability zone from the primary. Every transaction committed to the primary is synchronously replicated to the standby before the commit is acknowledged. When the primary fails, hardware failure, AZ outage, software crash, RDS automatically fails over to the standby. The DNS record for the database endpoint is updated. Your application reconnects to the new primary. The failover takes 60 to 120 seconds. During that window, your application will experience connection errors. Properly written applications should handle this gracefully. Connection retries with backoff. The standby is not a read replica. It doesn't serve read traffic. Its only purpose is to be ready to take over. Tom, how much does multi-AZ cost? Roughly twice the cost of a single instance, because you're literally running two database instances. The standby costs the same as the primary. Tom, and how much does an unplanned outage cost? He answered his own question by opening the order history and estimating the revenue per hour during their Friday peak. Multi-AZ was enabled that afternoon. Automated backups and point-in-time recovery. RDS takes automated backups every day. AWS stores these backups in S3. Managed by RDS, you don't see them directly in your S3 console. You can restore the database to any point within your backup retention period. Backups happen during a configurable maintenance window, a period of low traffic, typically in the early morning. For most engine types, backups don't cause downtime. Point-in-time recovery is one of the most valuable features. You can restore to any second within your retention period, not just daily snapshots, any second. This is possible because RDS continuously archives transaction logs in addition to daily backups. If someone accidentally runs delete from orders where 1 equals 1 at 2:37 p.m., you can restore to 2:36 p.m. Leo visibly relaxed when he understood this. Could we have recovered from what I deleted last month? He asked. Before RDS? No, said Priya. After RDS? Yes. Read replicas. Scaling read traffic. Multi-AZ is about availability. Read replicas are about performance. A read replica is an asynchronous copy of your primary database that can serve read queries. You can have up to 5 read replicas for most RDS engines, more for Aurora. The application is modified to send read queries to the replica and write queries to the primary. This distributes the load. The primary handles writes and complex transactions. The replicas handle reads. Key characteristics. Replication is asynchronous. There can be a small delay between the primary and replica. If you write a record and immediately read from the replica, you might not see it yet. Read replicas can be in the same region or in a different region. Cross-region replicas add latency, but enable geographic distribution. Read replicas can be promoted to standalone databases in a disaster scenario. For Nimbus, menu lookups are reads. Order history is reads. The vast majority of traffic is read traffic. Adding a read replica and routing reads to it cuts primary database load significantly. We cover read replicas more thoroughly in Chapter 24 when we discuss Aurora. RDS, parameter groups, and option groups. 2 configuration mechanisms that come up on the exam. Parameter groups control database engine settings, like maximum connections, query cache size, timeout values. RDS creates a default parameter group that works for most cases. You create custom parameter groups when you need to tune specific settings. Option groups enable additional features for some engines, like Oracle's native network encryption or SQL Server's transparent data encryption. Most open-source engine deployments don't need custom option groups. You don't need to memorize these. Know that they exist for customizing the database engine's behavior. Strengths and limitations. Why RDS is excellent. Eliminates the operational burden of managing database software. Automated backups and point-in-time recovery. Multi-AZ for automatic failover with minimal RTO. Read replicas for scaling read traffic. Encryption at rest and in transit built in. All major relational database engines supported. Where RDS has limits. You can't access the underlying OS. You can't install custom OS-level software or change operating system settings. If your database has requirements that demand OS-level access, you may need to run your own EC2-based database. RDS is not serverless, with exceptions. Aurora Serverless exists, covered in Chapter 24. You pay for a running instance even if it's idle. RDS is not designed for horizontally sharded databases. For massive scale-out of write-heavy relational workloads, you may eventually need a different architecture. For non-relational NoSQL data patterns, DynamoDB Chapter 9 is more appropriate. Summary. Amazon RDS is a managed relational database service. AWS handles patching, backups, failover, and storage management. You handle schema, queries, and application logic. Multi-AZ deployment maintains a synchronous standby in a different AZ. Automatic failover occurs in 60 to 120 seconds if the primary fails. Automated backups with point-in-time recovery let you restore to any second within the retention period. Read replicas are asynchronous copies that serve read traffic, reducing load on the primary. Replication lag means they may be slightly behind. Choose RDS when you need a relational database with managed operations. Use Aurora, Chapter 24, when you need higher performance or serverless options. Exam tips. SAA CO3, Domain 3, Task 3.3, Database Solutions. Multi-AZ is for high availability, not performance. The standby doesn't serve read traffic. Read replicas are for performance. This distinction is tested frequently. Multi-AZ failover is automatic. You don't configure when or how it happens. RDS monitors the primary and triggers failover automatically. Replication lag matters. Read replicas can be slightly behind the primary. If your application requires reading data it just wrote, it must read from the primary, not the replica. This is called read your writes consistency. Automated backups are retained for 0 to 35 days. Setting the retention to 0 disables automated backups. Manual snapshots are retained indefinitely until you delete them. RDS storage autoscaling prevents disk full outages. Enable it. It only scales up, never down. The exam may test whether you know this asymmetry. Exercise 1. Recall. In your own words, what is the difference between multi-AZ and read replicas in RDS? What problem does each one solve? Hint: one protects against downtime, the other improves performance under read-heavy load. They solve different problems and can be used together. Exercise 2. Exam practice scenario. A company runs a production PostgreSQL database on RDS. The database experiences high read traffic due to reporting queries running throughout the day. The team is also concerned about database availability. They cannot afford more than a few minutes of downtime in a failure scenario. They want to minimize impact on the primary database from reporting workloads. Which combination of RDS features best addresses both concerns? A. Enable multi-AZ and run all queries against the standby instance. B. Enable multi-AZ for failover protection and create a read replica for reporting queries. C. Create multiple read replicas and disable multi-AZ to reduce costs. D. Take more frequent manual snapshots and restore from them if the primary fails. Hint 1. The two requirements are 1. Availability during failure. 2. Offloading reads. Which features address which requirement? Hint 2. Multi-AZ provides automatic failover. The standby does not serve read traffic. So, multi-AZ alone doesn't help with the read problem. Hint 3. Read replicas serve read traffic. Multi-AZ provides failover. You need both. Answer B. Explanation. Multi-AZ provides automatic failover to a standby in a different AZ. This addresses the availability requirement. A read replica allows reporting queries to run without impacting the primary database. This addresses the performance requirement. Both features can be used simultaneously. Why not A? The multi-AZ standby cannot serve read traffic. It's exclusively for failover. Attempting to query it directly is not supported. Why not C? Read replicas help with read performance but don't provide automatic failover. If the primary fails, you'd need to manually promote a read replica, which takes time and isn't automatic. Why not D? Manual snapshots restore a full copy of the database, a much longer process, potentially hours for large databases. This doesn't need a few minutes of downtime requirement. SAA's CO3 Domain 3, Task 3.3, Exercise 3, Architecture Challenge Optional. Nimbus is considering migrating their existing self-managed PostgreSQL database running on an EC2 instance to RDS PostgreSQL. The migration needs to happen with minimal downtime, ideally under 15 minutes. The database is 200 GB. What approach would you recommend? What AWS services might help with the migration? What risks would you test for before cutting over production traffic? There is no single correct answer. Think about AWS Database Migration Service, logical replication, and the risk of data inconsistency during cutover. Nimbus had migrated to RDS PostgreSQL with multi-AZ enabled. The migration itself took most of the afternoon. Leo used a backup and restore approach with a brief maintenance window. Tom had watched the bill carefully. The RDS instance, he said, costs twice what the EC2 database did. And the automated backups? Maya asked. A bit more. And the failover that we'll get for free if the primary dies? Tom didn't have a price for that. He wrote it down as a question. 3 days later, the database was healthy. Query times had dropped somewhat, but not enough. The menu was still slow to load. 22,000 items. Rows in a query that returned all of them, every time. The problem, Priya said, isn't the database engine, it's the data model. She paused. Some of this data isn't relational at all. Menu items, restaurant profiles, delivery zones. This data has variable shapes. SQL is fighting us. Leo was already researching something. What if we used a different kind of database for the menu, he said. In the next chapter, the database that doesn't slow down, even when a million people order at once.